Hello everyone, this is Usha and my team members are Veena and Vatsala. Our project title is Smartphone Price Prediction for Retail Industry under the guidance of Professor Chandrasekhar KD. So here what we are doing is, we are using the 5 different machine learning algorithms, that is support vector machine, linear regression, backpropagation, regression trees and model trees. At last we'll be comparing the results of all these 5 models and we'll be concluding that which model is giving more efficient or more accurate value when compared to the other models. So before applying all these 5 models, what we'll do is we'll collect the data and we'll be doing the data pre-processing. After pre-processing, we'll be applying all these 5 models and we'll be comparing the results. So we'll start with the data pre-processing. For data pre-processing, first we'll read the data. Data pre-processing is nothing but converting and transforming the raw data to understandable format. So first in data pre-processing, we'll read the data. So this is our data set with the different features. Here we have 16 features and 262 rows, that is 262 brands. Then what we'll be doing is, after reading the data, first we'll apply the lapply function, which we used to convert the lower case to uppercase just to make a uniformity. So to make uniformity, we'll be using lapply function. So after executing this function, here, the lower case got converted to uppercase. So here, after converting that, we will be deleting the duplicate entries. So after running that function, so here we can see that before we had 263 data sets, right now you have 262 after deleting the duplicated entries. So before applying the 5 models, here we'll be assigning some indexes to all the factors, because while applying the models will not work for factors. It takes only numerical values as an input. So here we'll be assigning the numerical values to the factors. Like for brand, all different brands will assigning the 1 to 22 numbers for all 22 brands. Same thing for the different features like OS, color and all. So we'll start with execution. So after executing this, so after deleting the redundant entries from the data sets, we'll be assigning some indexes values to the factors, because while applying the different predictive models, we should supposed to give the only numerical values as an input. So here the brand, like different brands will be assigning the different numbers, for same thing as like for OS and colors. So we'll see the execution. So after executing this, we can check with our data set. That it got converted to the values which was there in the factor before. So after doing that, here again in our data set we have before we had units like EMP and all, that also we have converted it into the empty space. Here we have something like GB and all. If we find the GB in the particular row, as like in a RAM, so we will replace that with the empty space which we have already done. We can see here this empty, and here the memory and RAM and all. So same thing for, we'll be doing same thing for display. Wherever we have units, we'll be replacing it with the empty space. after doing that, here what we have is, for example, if any of the column price is not there, we'll be deleting that particular row, because that row would be which is of no use, because we'll be comparing the price, predicted price, with the actual price. If that particular row doesn't have the price, then we'll delete the same. And if any of the particular column has no values, or then we'll assign it to some other values, just to for comparing the results. So we'll execute this. So after deleting the price and assigning some values for the missing rows, so we'll execute all those functions. And if any of the columns like weight and all, if it is missing, we'll take the mean of all those. So here we can see that right now our data set has 262 rows and 16 columns, and we have got a pair versus graph. Each pair is versus with other all features. This is the pair graph. So here we are going to convert or divide our data set into two parts, as for training data set and for testing. For training, we'll be having 80% of our data set, and for rest is for testing. Here the replace function is equal to false. What it does is, it won't take the repeated row for training. So after applying the pre-processing, we'll start with our machine learning algorithms. So that first we'll start with the SVM. So we'll execute the SVM. In SVM, the first thing here what we are taking is, we are going to do the feature selection. That here we can see the 3, 7, 11, 12. These are the columns which we are going to remove from our data sets, because these features won't affect while predicting the price of smartphones. So we'll take it as we'll be removing from our data sets while predicting the price. And then these are the data sets, training, reference and testing data set. And here the library called E1071, this is a package for executing the SVM functions. There is a built one. So after executing SVM, so here we can see the actual price with the predicted price. So what the actual price is 11,999, whereas the predicted one 12,537. So what we'll do here is, here we can see the R2, that is R2 square value, which is 0.85, whereas the correlation value is 0.92. Correlation value should be in the range of -1 to 1, and then whereas R2 value should be 0 to 1. That means it's giving more efficiency. So this is the graph for SVM. Here we can see the blue point indicates that actual value, and the red one indicates the predicted. So this is the actual value and this is the predicted value. So we'll go with the linear regression. Linear regression. Here we have the values, again same thing like what we had in the SVM. we can see here the R2 value is 0.74 and whereas the correlation value is 0.86. So when compared to the SVM, this is giving little less efficiency compared to SVM. So we'll start with now the next model. That is back propagation. We'll execute that. So this is about graph, back propagation graph. So these are all the features which we are taking to predict the price. These are the features that affect while predicting the price. This is the hidden layer and this is the predicted one. So when we compare the values of R2 and COR, here the 0.87 R2 value is 0.81 whereas the correlation is 0.90. So still now we have seen the SVM, linear regression and back propagations. So now we can conclude that compared to the linear regression and back propagation, SVM is giving more efficient value or accurate value. So once we finish with the back propagation, we will go with our next model, that is regression tree. So we'll execute that. So in regression tree, what our R2 value is 0.024 whereas correlation is 0.49. So when we compare these values with other previous models, so this is the very less accuracy in compared to the other models. So this is the graph for regression trees. So after regression tree, now we will go with our model tree. We'll execute that function. So here we have our value 0.67 whereas the correlation is the 0.81. So after executing all our models, what we can conclude over here is, when compared to all other models, SVM is giving the more accuracy. So first one is SVM, that is support vector machine. Second one is linear regression, next back propagation, then regression trees, and then model tree. So here SVM is giving more efficiency. Thank you.